The system here one by one, 0 x equals to b. So you saw that is a itself is 0, and if it is multiplied with x equals to b, has one equation, one unknown, and automatically has two possibilities here. So when you are having 0 vector, it is multiplied with x equals to b. So what will be the solutions? It has no solution unless b is equals to 0. If I say b is equals to 1, is this possible? 0 multiplied with a vector span x and b equals to 1. It is not possible. So it will have a solution only when b is equals to 0. So it is 1 cross 1 0 matrix contains only b equals to 0. If that is a unique solution when b is equals to 0. For this you have only one solution, that is and that solution is when b is equals to 0. So if I move on to if b equals to 0, if I write the expression 0 x equals to 0, so I can have indefinite values of x, and so automatically I can say 0 x equals to 0 has many solutions. So the null space contains all the x. X can be positive, x can be negative, x can be any value. So when you multiply it with a 0 vector, you will get a 0 vector. This we can call it as it contains many solutions. So here what will be the complete here? So here you had one possibility, that is OX equals to B. So that I can, a particular solution XP is equals to 0. What will be the solution for this? That is XP is equals to 0. And the complete solution, when I solve that complete solution, OX equals to 0, this is your null space. And that contains all the X. So your particular solution is 0 because b is equals to 0, and all the vectors containing only b equals to 0 will be the solution. And for null space, this null space you are having the many solution because x can have any values. So any values of x, this will be a complete solution. Here, next problem, if I look into the next problem, the matrix given is 1 by 1, 2, this is one vector, and another vector is also 1, 2. So the vector u is equal to vector v. If I look at this column 1 and the column 2, both are equal. So in this, if I just define what vector this as y and this as z, y plus z equals to b1, that is 2y plus 2z equals to b2. This is your second row expression, and this is your first row expression. Usually have no solution. In this you have to check whether it has a solution or not. So here there is no solution. So you can see y plus z is equals to b1, and 2y plus 2z should be equals to b2. So automatically this tells you that b2 should be 2 times of b1. Then only both the equation will have a solution. Otherwise, will not have a solution. If b2 is not equals to 2 times of b1, you will not have any solutions. It is saying something like 1 plus 2 is equals to 3. Okay. So if I say twice that is 2 plus 4 should be equals to 1, it will be equals to 6. Right, that is also, it should also be 2 times. If I cannot say that 2 plus 4 is equals to 8, right? So similar, in that itself, that is b2 is equals to 2 times of b1. So here a contains only those b's and the multiples of 1 and 2. So given the b1 and b2 should be, b1 should be, see here you have a row, first row as 1 1, second row as 2 2. So it is second row also should be, b also should be 2 times of b1. So you'll have, there are infinitely many solutions if when b2 is equals to 2 times of b1. If this is satisfied, then you have infinitely many solutions. You can have the vectors can have the vectors here. If I can have y as 1, z as 2, and y can be 2 and z can be 2, any number of values y and z, until only one particular restriction is that B2 should be 2 times of B1. If that condition is satisfied, you have n number of solutions or infinite solutions. So we can have infinite solutions here. And a particular solution, that is y plus z equals to 2, and this is one space xp equals to, if I am taking y plus z equals to 2 and 2y plus 2z equals to 4, that means xp is equals to, particular solution is 1 1. So I can have and what will be the null space? Null space is, how do you find the null space? If I restrict this, that is b1 is equals to 0 and b2 is equals to 0, what I'll be getting? Y is equals to minus z. In both the expressions, I'll get it as y equals to minus z. So here, if I'm writing the expression, so what are the contents of null space? Minus 1 and 1. Y is equals to minus z if I write in terms of z. So what is the value of z if I am writing? So z is equals to y plus z is equals to 0 you have got. So z is equals to minus y. So you have, if z y is 1 minus 1, so z will be 1. Or you can have it the other way also. So the particular null space solution is minus and 1. And whereas the particular solution you had y plus z equals to 2 or 2y plus 2z equals to 4. So if you have y equals to 1 and z equals to 1 or the multiples of it, you can have it as a multiples of that 1 and 1. So this is particular solution, and this we call it as a null solution. This is your null solution. That is b being, when we solve it for b equals to 0 and we are solving it for y plus z equals to 2, and that is b you are taking it as 2 and b2 you are taking it as 4. If you solve this, you will be getting y equals to 2 minus z, and here z will be equals to 2y equals to z. One equation will be getting it as y equals to 2 minus z for particular solution. So if I take z equals to 2, if I am taking for the particular solution, y plus z is equals to 2. So what will be that? Y will be equals to 2 minus z. So if I have both from both the expression, you will be getting the same type. So if I take z equals to 1, so if I take assign this equals to 1, what will be the value of y? Y will also be equals to 1. So that itself is a particular solution 1 comma 1. Whereas in null solution you have y plus z is equals to 0. So y is equals to minus z. So if I have y equals to 1, so y equals to 1, then z has to be minus 1. Or I can have y equals to minus 1, so z will be equals to 1. So the same particular solution has been taken here. Null solution has been taken. So some complete, and this is your complete solution, the right way of writing complete solution. This is the particular solution that we have seen here, and this is your null space, because I can have any value for y equals to, because it is y equals to minus z, so you can have any value. So the total solution will be, if I am combining with 1 minus c and 1 plus c. So this is about the vector